Do we have an assignment?
Yes, you have 2 assignments over this. I am not kidding. So I never joke about calculus. Here we go. Click them close. Take a look. So part A, we don't have to verify it. We'll just take it for granted that it is. Determine the equation of a line tangent to the curve here. So what are we doing? So we're differentiating. Good. How are we going to differentiate this? Not indefinitely. We're going to, what are we going to do?
Take the derivative of y with respect to x.
Implicitly differentiate with respect to x. There you go. So if we do that, what's the derivative of sine y with respect to x? Good. Plus equals 2y y prime. Okay? Okay, so we want to know what y prime is, right? That's all we need to know. So do we really need to be simplifying this whole thing? No, not really, right? We could just plug in now. We could just plug values in for x and y. So there are no x's, right? All there are, we only get y's left. So I'm just plugging pi in for y. So if I evaluate this thing, what do I get? If I evaluate it at pi, cosine pi is -1. So I'm just going to get, so that's really just negative y prime, right? Plus 2 equals 2y y prime. Well, that's just 2 pi y prime, right? Okay. So then solve for y prime. Well, I would just maybe add that y prime to this side and divide, factor out a y prime and divide. So what does that give me? If I solve for y prime, what is y prime equal to? What's going to be on the top? 2, right? That 2 goes on top. On the bottom, it's going to be 2 pi plus 1, right? Because I've got to push this term over to this side. I got to add a y prime and then factor out y prime. Anybody see that? So if I factor a y prime out, I would just get 2 pi plus 1. Okay? Everybody see that? Give me 1 to 5 on that. Okay? Okay, I'm going to show that step. So then this gives us, if we do all that stuff, we get 2 equals 2 pi y prime plus y prime. If I factor out a y prime, right? And now if I divide each side through by 2 pi plus 1, doesn't that just give me that? Okay, good. That's ugly, but that's just a number. So now when we want to do our tangent line, that's my slope, right? That's just the slope of the tangent line. And this is my point. So then I'm just going to get y minus pi equals m, which is this guy, 2 over 2 pi plus 1 times the quantity x minus pi squared over 2. Okay, that's my tangent line right there. I don't really have to, I mean, I could distribute the blue is, yeah, right? it's not written in a very good form. It's not written in slope-intercept form.
Could you put that in like to Pearson that way and it would be right, or would you have to put it in slope-intercept?
I don't know. It'd probably tell you on the answer what it wanted. I mean, we could, like, all we'd have to do, though, is distribute that big, ugly slope, which isn't the worst thing in the world. Let's just do it. Let's just do it.
It's a little bit tough. I like avoiding those head.
Okay, so what do we do? What do we get here? So if I distribute this whole thing, right, I'm going to get 2 over 2 pi plus 1 x minus 2 pi squared over 2 times the quantity 2 pi plus 1, right? What's the last step?
Cancel the 2.
Yeah, cancel the 2's, good. And add pi. So my final answer, I feel like I'm talking over people. That's not good. So if I add pi, I'm going to get y equals, my slope is, so I get 2 over 2 pi plus 1 times x, there's mx, plus b. So I would add pi, so plus pi minus pi squared over 2 pi plus 1. That's fine. What else are you going to do? Just leave it like that. That's just some big number. That's b. Okay? But that's the line. Okay? Okay, I don't know if we even need to do this whole problem, but I want you guys, I want to make sure you're good with the process of calculating a second derivative using implicit differentiation. So, what do I do? Differentiate everything. So derivative of 9x is 9 plus equals cosine y, y prime. Okay, now I want to calculate a second derivative, so don't change it, right? We don't want to turn it into a quotient, we just want to keep differentiating to get our second derivative. Along the way, though, well, we'll leave it like this. We won't do anything with y prime yet. We'll just take our second derivative. So if I differentiate again, what's going to happen? Derivative of 9 is 0, okay? The derivative of 3y prime is 3y double prime. The derivative of cosine y, y prime is, okay, is negative sine y, y prime squared. Everybody see where we get that? That's the first part of product rule, right? We did the derivative of cosine y, which is negative sine y, y prime, times y prime, hence the y prime squared, right? Plus, what's the second part of the product rule? Cosine y times y prime squared, which is y double prime. Okay, so now, does that make sense? Derivative of y prime would be a y double prime. Okay. Okay, I'm going to leave it there. Questions? I don't want to go too fast. Questions? If you have a question on any of those steps, raise your hand and let's make sure we're all on the same page. Okay. Everybody sees how we got the y prime squared. One y prime was from the derivative of cosine y. The other y prime was because we were multiplying it by that y prime. Okay? All right, so now we could, let's see, what would we do here? To solve for y prime, let's let's put the y primes on the right side so this term becomes positive. How about? Okay. So then we're gonna get, next step would be positive sine y y prime squared equals cosine y minus 3 all times y double prime, right? If I subtract the 3 y double prime to the right side and factor out a y double prime, okay? So the last step, I'm just going to divide everything by cosine y minus 3, but what do I still have to do? I still have to plug in y prime, right? So I got to go back, and I call this side work. We got to go back and do a little side work up here, where we're going to move out of the vertical flow, but we got to find out what y prime is. So if I solve for y prime by subtracting this term to this side, here we'll go, I'll give a little more room over here. Then I'm going to get, on the right side, if I subtract this term to the right side, aren't I going to get y prime times cosine y minus 3 on the right side? Anybody agree? On the left side, I've got my 9. And so that allows me to solve for y prime. So y prime is just going to equal 9 over cosine y minus 3. Does that make sense? Give me 1 to 5 on that. Right? And all we did was we did side work from this step to solve for y prime, to isolate y prime. Okay? What do we do with that? Well, now we're just going to end up plugging that in down here into our answer for y double prime. So if we continue to solve for y double prime is equal to, I'm going to divide each side by that factor. So I get sine y over cosine y minus 3 times y prime squared. Well, there's y prime squared. There's y prime, right? So y prime squared is just going to be 9 over cosine y minus 3 quantity squared. Anybody see that? Good? And so we're pretty much done then. 9 squared is 81. So I get 81 sine y. What am I going to get on the bottom? Cosine y minus 3 quantity cubed. Exactly. Right? Because I'm multiplying that times that, right? Good? Okay. Oh, that's next time.
No, I was saying how we have to prove the derivative of ln. The next page, the first part was different.